This week we're going to be learning about how to balance chemical equations, and this is also known as a chemical reaction. And a lot of times people will call it a chemical equation when you're in the process of trying to balance it, because basically an equation means something is equal to something else. And in chemical reactions, that means everything on the left side needs to be equal to everything on the right side. And so that's why it's called an equation. Okay. So I'm going to use this simulation, and we'll be using this in class this week a little bit to kind of help us start to think about how we can get both sides to be equal and what that would look like with a visual model. Okay, so if we're having this reaction happen, we need to have at least one of everything. So I'm going to go ahead and add one of each of these molecules or compounds. And as you can see, there's this little scale up here, and it's showing us that in the reactants we have 2 nitrogens, and in the products we only have 1, so it's not balanced. You can see that again down here. We got 2 blue nitrogens in one molecule and 1 blue nitrogen in the other molecule on the product side. So since there's 2 blues and 1 blue, it's not balanced. And we can see that again down here. 2 N's versus 1 N, not balanced. Same thing is true when we look at our hydrogens. We have the 2 hydrogens from the left and the 3 hydrogens on the right. They're not equal to each other, so the hydrogen is also off balance. So what we can do is try to get our nitrogens to be equal to each other. We have to look at which side has less nitrogen, and this side has less nitrogen. There's only 1. So to get it to be equal to the left side, I'm going to add one of these molecules. This is like changing our coefficient, and we'll talk about all that in just a minute. So I add another molecule here, and now I have 2 blues and 2 blues on this side, which represent my nitrogens. And if you look up here, the nitrogen scale is now balanced. The only thing we need to change now is the number of hydrogens. So on this side, we have 2 times 3 hydrogens, 6 hydrogens. And on this side, we only have 2. So think about it. What do I have to multiply this by in order to get 6? I need to multiply by 3. So once I get 3 hydrogens here, or 3 hydrogen molecules, I have 3 times 2. That gives me 6, and you can see them here in the picture. And now I have 6 on the left and 6 on the right, so it's balanced. And you can't see it, but there's a little smiley face at the top telling me I did it right. Okay. Now I'm going to teach you how to actually follow some steps and solve them on paper. So here are the steps I'd like for us to follow for balancing chemical equations. So first you need to be able to separate out your reactants from your products. I'm going to fill that in with products. Okay. That means you're cutting your reaction in half at the reaction arrow. So I'll put an arrow here to remind you that that's where we do the separation. Reactants are to the left, products are to the right. Okay, so that's what my R and P are representing. All right, next we need to tally or count the number of each element on both sides. So calcium, bromine, carbon, all these types of elements. All right. After that, you will figure out or evaluate which side has less of a specific element. Okay, and then you'll just write a coefficient that will allow you to multiply the compound by a number. That coefficient needs to allow you to multiply by a number that will give you the amount of the element that you need in order to get it balanced. So we'll talk about that in a second. And then you continue until your entire reaction is balanced. It's kind of like a puzzle, it's kind of like a game in my mind, until you can get your whole reaction to be balanced. And so it might take some trial and error, and you might have to go back and fix things. Okay, so we're going to start with this reaction. And we have lead oxide, PbO, reacting with sodium chloride to produce lead chloride, PbCl2, and sodium oxide, Na2O. Okay, so I went ahead and I'm going to separate my reactants from my products. I'm going to draw this little line here. Okay, so I have all my reactants over here. I have all my products over here. So I'm going to tally up the number of each element. So with no coefficient here, I only have one lead because it doesn't have a subscript. So there's one on this side. If we look on the product side, I also have one lead. Okay, oxygen on the left. I have one oxygen because it doesn't have a subscript either. And I have one oxygen on the right. Next I have sodium. There's one sodium on the reactant side, but there are two sodiums on the product side because of the 2. Then we get to chlorine. I have one chlorine here. I started to write a subscript but realized that was a mistake, so I crossed it out. Sorry about that. One chlorine, and here I have two chlorines on the product side. Okay, so you can see pretty quickly that the two things that are not equal to each other on both sides are my sodium and my chlorine. So that means I'm going to need to balance those. So the step after counting was to figure out which side has less. This side has less. Okay, so we're going to need to multiply this side by something. The compound that has sodium and the compound that has chlorine happen to be the same one. What number do I need to multiply by 1 in order to get 2? Because I want it to be equal to this. I'm going to need to multiply by 2. So I put my coefficient of 2 in front, and that takes my 1 sodium and multiplies it by 2 to give me 2 sodiums. Same thing is true for my chlorine because this applies to everything in the compound. 1 times 2 gives me 2 chlorines. And now everything is balanced. I'm writing and you can't see it because of the screen. There we go. Balanced. Alright, now let's move on to a couple more examples. We have copper reacting with aluminum chloride to make aluminum and copper chloride. So I'm going to do the same thing I did before. Dashed line to separate out my reactants and my products. That's a very ugly dashed line. Reactants and products. Okay, let's tally them up. I have just one copper. On this side I have one copper. I have one aluminum, and on this side I have one aluminum. And then for chlorine, on the left side I have 3 chlorines, and on the right side I have 2. So clearly the things that are not equal are my chlorines. And this might take us a little bit of work here. There is nothing, so we know that 2 is less than 3, but there is nothing that I can multiply by 2 that will give me 3. That's a whole number. I can multiply by 1.5, but that's not a whole number. So I need to find a whole number. What I need to do is I need to figure out what does 2 go into, that's a smaller number, and what does 3 go into. Both of these can go into 6. So what do I have to multiply by 2 to get 6? I have to multiply by 3. So if I put a 3 here, I get 6 chlorines, because 2 times 3. Then on this side, I have to multiply by 2 in order to get 6. So that means I need to put a 2 in front of my molecule that has chlorine. 2 times 3 gives me 6. Now this is going to change some things. This changes my number of aluminums on the left side. Now I have 2 aluminums. And this changes my number of coppers on the right side. Now I have 3 coppers. So I'm going to go and fix the number of coppers because now this is not equal to this. Okay, so this side has less copper, so I need to multiply by something that will give me 3. I need to multiply by 3. And that gives me 3 coppers, and now that's balanced. Then lastly, I need to get 2 aluminums. Sorry about that, Belle. I need to get 2 aluminums. So I'm going to have to multiply 1 by 2 in order to get 2. So that means I need a coefficient of 2 up here. Okay, so now this is the balanced reaction because all of our coppers are equal, all of our aluminums are equal, and all of our chlorines are equal. Okay, this is the last example I'll go through, and I'll try to do this pretty quickly. But in general, combustions can be tricky because you have oxygen in both the carbon dioxide and water as your products. And so in class I might teach you guys a little trick to help you with combustion because there's a certain order that you want to balance things in. And actually, I wrote it out already naturally in that order because I'm so used to doing it. Carbon is the first thing you should balance, then hydrogen. And if you end up with an odd number of waters, then you would need to multiply everything by 2 and then continue balancing, okay? And then oxygen is going to be your last thing because oxygen is the hardest part since it's broken up into 2 different molecules. So that's kind of the order that you can do a combustion in, so it's good to always write it out this way so you remember. Okay. So let's start out by tallying like we did before. We have 2 carbons here, and on the right we have 1. We have 4 hydrogens on this side, and we only have 2 on the right in our water molecule. Then we have 2 oxygens on the left, and on the right we have 1, 2, 3. So they're broken up into 3 separate things, or 2 separate things. Okay, now, nothing is balanced. But like I said, we can start with our carbons and use that to help us balance. So starting with carbon, this side has less carbon. So what do we need to multiply 1 by to get 2? We need to multiply by 2. So I'm going to put a 2 right here. And I have 2 CO2s now. That also changes my number of oxygens. So now I have 2 times 2, 4, plus 1, 5. So I'll cross out my 3 and I'll put 5. Always make sure you change the numbers after you've put a coefficient if it changes anything. Alright, next I need to balance my hydrogen. On the left I have 4, on the right I have 2, which is less, so that means I need to multiply this by something. I need to multiply 2 by 2 in order to get 4, so that means my coefficient here has to be 2. 2 times 2, 4, but then also 2 times 1 oxygen, that's 2, plus, we knew we had 4 here before, 2 plus 4 is now 6. So I now have 6 oxygens on the right. My last step here is going to be to balance my oxygens. So I have 6 on the right and 2 on the left. So I need to multiply this by something that will give me 6. 2 times 3 gives me 6. So that means the number that goes up here is 3. And now everything is balanced. And if you want to fill in every spot, you could always put a 1 here just to represent that there's one of those. Okay? So just remember, the coefficient is the only thing that you're changing in the reaction to balance it. You cannot change the little number. Never, never, never. Because that changes what substance you have. And you can't do that. That's not the reaction. These substances are the reaction. And so you can just change the ratio of how many molecules there are to one another in order to get a balanced reaction. So that's what you're doing when you put in coefficients. All right, let me know if you have any questions about any of these problems or other examples.